thank you so much for coming. Please enjoy the cronuts and champagne. And without further ado, I'd like to introduce the co-founder and one of the original designers of Tor, Roger Dingledine.
Thank you. Okay, so I'm Roger, and everybody can hear me okay? I'll try to keep yelling at this volume for as long as it takes. So I'm going to try to pack a bunch of different talks together. Feel free to interrupt me if I say something that doesn't make any sense, and we can talk about the thing you wanted to talk about also. I've got plenty of material and too many talks and too many slides, so I'm gonna try to cover a lot of different things at once. And you'll find me messing with this microphone that the video guy gave me because it doesn't really stick, and it's hidden underneath the Tor shirt. Okay, so part of the goal of Tor, we're a nonprofit. The main way that you would have Tor is called Tor Browser. It's a variant of Firefox. You install it on your computer. And the idea is that Tor Browser builds a path through the Tor network. And the goal is that somebody watching your internet connection can't learn what you're doing on the internet. And somebody at the website or other destination you go to can't figure out where you are on the internet. And no single point in the middle gets to track what's going on, gets to build a database about what's happening. So I'm going to keep coming back to those security goals as we keep going. So what is Tor? Tor is a bunch of different things. Tor is that network I was talking about before. Tor is a nonprofit organization. We pay people, mostly developers, to research how to make Tor better and to actually make the software stronger. The other fun thing about Tor is that we're a community of researchers all around the world. Basically, every city that I go to has a university professor doing Tor research and a pile of interested grad students who want to understand how to make things stronger or faster or break them or think about censorship and so on. So part of the fun of it is that everywhere we go are people who are part of the broader Tor community. Okay, so a little bit of history. I'm going to mess with the microphone a little bit more. Am I audible still? Yeah. Okay, great. So we started off, I started off working on Tor stuff in 2001 or so when we wrote the first program called Tor. It started based on a project at the Naval Research Lab called onion routing, which is one of the underlying cryptography primitives. I'll be the person who says crypto meaning cryptography up here. And we were first funded by some of the US government money, and we'll get into that as well. From there, we were funded by the Electronic Frontier Foundation. So our claim to fame early in the process was we're the only group to be funded by both the EFF and the US government for the same free software privacy system. And from there, we became an actual nonprofit in 2006. And then I'll cover a bunch of these topics later on in the talk, but from there, 2007 got interesting because Tor is a privacy system, and then we started getting mail from a lot of people in China and Iran and Vietnam saying, this is awesome, I'm getting around my government censorship. And then I was thinking, there are 6,000 or so public relays, and the IP addresses are all public, and you just get it, and that's how the network works. So China's just going to download the list and block them all. What do we do? So that started the whole censorship arms race that I'll talk about later. And then we've got the Arab Spring we can talk about, and Ed Snowden came out with some interesting documents a while ago. Here's my microphone. I'll hold it up next to me. So how many users are there of the Tor network? We've got two different estimates that people have been working on lately. The original estimate is something like 2 million daily users on average, and we don't know how many of those change from day to day. So is it 2 million who use it every day, or is it 14 million who use it 2 million per day? And there's a much more recent estimate that we think is more accurate that shows about 8 million daily average users. So there are a lot of people out there using Tor. So thinking about this from the computer security perspective, the first thing you ask is, what's the threat model? What are you trying to protect against? So we've got Alice over here. She's trying to connect to some website called Bob. Where could the attacker be? What could we be worried about? So maybe the attacker's watching Alice. Maybe that's Comcast or the Monopoly telco in Tunisia or the Starbucks or something like that. Or maybe the attacker's at the Bob side. Maybe they're watching WikiLeaks and they want to know who is connecting to WikiLeaks so that they can build a list or something like that. Or maybe the attacker is Bob. Maybe it's the destination website. It's CNN or something, and they want to know who their users are so they can advertise to them better. Or maybe the attacker's somewhere in the middle of the network. Maybe it's AT&T or Deutsche Telekom. I guess that means it's NSA and other large agencies that try to watch the internet. So if the attacker's in all of these places I just talked about, we're screwed. We can't protect against that. So I'll get into all of that more in a bit. But before I get there, an important thing to remember, anonymity is not the same as encryption. I talk to a lot of corporations who say, well, yeah, but we use a VPN, we use encryption, we're totally safe. You should use encryption. Encryption is good, but even when you're using encryption, somebody watching your network traffic gets to learn who you're talking to, when you're talking to them, how often you're talking to them, and that network metadata is where all the interesting stuff comes from. I was talking to somebody from one of the three-letter agencies a while ago who said, yeah, we never try to break encryption anymore. Nobody tries to break encryption. It's all about, let's build the social graph of who talks to who. Let's figure out who's in the middle of that social graph, and then we break into their house and install something on their computer or steal their laptop or blackmail them or whatever we have to do. So metadata is the name of the game. Hopefully everybody here has seen Creepy NSA Guy and his quote, "We kill people based on metadata." This was an actual director of the NSA who said this. And I guarantee there's the equivalent person in Russia who says in Russian, "We kill people based on metadata," and the equivalent person in China, and so on. It's all about figuring out who's talking to who, and therefore who is interested. Okay, so I actually only use the word anonymity when I'm talking to other academic researchers. When I'm talking to my parents and grandparents, I explain I'm working on a privacy system because anonymity is a bit scary, but privacy is a good Western value. Of course, we all need privacy. And when I'm talking to companies and Walmart and Google and so on, I work on communication security or network security. Because privacy is dead, anonymity is confusing, but of course I need security. I'm going to check out my vendors or something, and I don't want somebody watching my network connection to learn where I buy my supplies from, or what things I'm thinking about patenting, or all the things that companies do on the internet but don't want connected with them. We were hearing a while ago that Goldman Sachs uses Tor pervasively inside their network because they don't want the competitors to learn what stocks they're researching and what they're thinking about doing next, which makes a lot of sense. And then when I'm talking to governments and militaries, it's the same stuff, but I work on traffic analysis resistant communication networks. Again, it's the same security properties, it's the same network, but figuring out how to frame it for them so they understand what's going on. Because you go to the government and you're like, I've got a security tool for you. They're like, no, I've got plenty of security tools, I don't need that. And if you explain that you've got a privacy tool, they don't know why they would need privacy. But then you say, I have the ability for your diplomat to go to Israel and resist traffic analysis of somebody trying to figure out why your diplomat is in Israel today, or why that hotel has a whole lot of people from that company in it right now. That's the sort of protection that they're thinking about. And then there's a fourth category, which is the human rights side, the reachability side. I'm in Turkey and I can't get to BBC. How do I get around the blocking that's going on? So the fun thing about Tor is it has to be the same network because you have to get all these different users together so they can blend together. You can't have a Syrian political activist privacy network because then everybody who uses it, you know why they're using it. You can't have a cancer survivor's anonymity system because then the fact that you installed it tells people about why you installed it. Okay, so how do you actually build one of these? The easy answer is the centralized version. You put some centralized anonymizer or VPN or whatever you want to call it, and users ask it for the website, and it fetches the website and gives it back to them. And the first problem is, what if that big central point of failure fails? Maybe they collect your data, maybe they sell it. It's hard to know. I mean, you've seen this business model over and over where they say, we promise we never look at any of your traffic. Okay, actually we do look at all of your traffic, but we promise we won't write it down. Okay, actually we do log everything, but we promise we won't sell it or anything. Okay, we sell it, but not that much. And a while ago there was like hidemyass.com or something, which is it ended up turning over a lot of data about users, and the users are like, what the fuck, you're named Hide My Ass, and they're like, well, what did you expect? So part of the challenge here is the centralization. I was talking a long time ago to, I think it was the CTO of anonymizer.com, and he was saying, we never answer subpoenas. If we ever answered a subpoena, then nobody would ever trust us. So of course we never answer subpoenas. And then I was doing a talk for the US Department of Justice like 6 months later, and one of them interrupted me and said, why can't you be like Anonymizer? It's easy. We send them a subpoena, they send us an answer. It's easy. Why can't you be like that? So I say that not to pick on a particular company. The problem is the model. The problem is the centralization. They have all of your data. They could screw you. They promise not to screw you. There's no way for you to know. Maybe their business model changes. Maybe they mean well. So it's worse than just the centralization. Even if they are completely magically perfect, it's still one cable coming into that central point and the same cable coming out. So if I can monitor that central point on the internet and see the patterns of traffic coming in and the patterns of traffic going out, I can match up which user is doing what. So even if you find the world's most magical VPN provider who actually does follow through on their promises and they're completely resistant to blackmail and their business model never changes and so on, it's still the centralization on the network is bad news, because if you can watch that traffic, you get to learn everything that everybody's doing. So the goal of Tor is to distribute that trust over multiple hops, multiple relays, so that no single point gets to learn what you're doing. So Alice connects through 3 relays. The first relay knows that Alice is using Tor, but doesn't know what she's doing. The third relay knows somebody is talking to Bob, but doesn't know who it is. And no single point here gets to know both of them. If the attacker is able to watch this area and also this area, then in theory they can do timing and volume correlation to match up, wait a minute, this flow that I see over here seems like it matches up with this flow that I see over here. In theory, that attack works pretty well. In practice, nobody knows how well it works at scale with millions of users. There have been a bunch of laboratory studies that show that it works in a small scale, and it's an open research question how bad that is in practice. So the goal of Tor is to have a lot of these different relays in a lot of different places. And the more relays we have and the more diverse their locations are, the harder it's going to be for a particular attacker to be able to see enough of the network in order to try to piece things together. So far, so good? Am I going too fast, too slow? Awesome. And there's cryptography. I'm mostly going to leave that alone at this point, but so the basic way that it works, Alice builds a TLS connection, an encrypted channel to the first relay, and then she extends that from the first one to the second one, and then she extends that to the third one. And the type of cryptography that we use provides a property called perfect forward secrecy, which means even if you break into R2 later and say, I know you were part of this circuit, decrypt this traffic, I logged the traffic, here it is, decrypt it for me, there's nothing that the relay can do to recover what was actually sent back and forth because of the way that we do the cryptography. Okay, so that was actually only half of what Tor is. That was like the network level side of what Tor is. The second piece is the browser side, or the application layer. So the first piece is, how do I get my traffic from here to there safely? And then the second piece is, what am I sending as my traffic? Because if you hook up your unpatched Internet Explorer to the Tor network, you will be sending a bunch of identifying things. You'll go to a website, they'll send you some JavaScript, you'll send them whatever, your Windows serial number and so on. So Tor Browser tries to deal with all the application level things. You've heard of cookies and Flash and so on. It turns out there are hundreds of other things like that, which fonts you have installed on your computer, which version of this, which language you prefer, how many pixels by how many pixels your browser window is. All of that is stuff that the websites you go to can learn about. So the goal of Tor Browser is to make all the millions of Tor users be the same, is to make them all blend together into one group of people. It's not to make you look like everybody on the internet. We don't know how to do that. It's to make you look like the next person using Tor Browser. There are other ways of using Tor. There's an operating system called Tails that's based on Debian, and it has Tor Browser, and it has all the applications that you should want pre-configured and ready, and it's missing all the ones like Microsoft Word that are bad news to use if you want to stay safe on the internet. So there are a lot of more of the activist-y side of the world uses Tails, but also journalists, if they're handling interesting leaked documents, tend to be Tails users because they want an entire environment in a VM that is all working for their privacy. So far, so good? Okay. Recently, we have finally gotten a Tor browser for Android going, and we're going to be putting out the stable release, I think, next week or something like that. So it took us a long time because there was no Firefox for Android until recently. And because Tor browser is based on Firefox, we needed that to exist. So the good news is we're going to have Tor browser for Android as a first-class citizen. The bad news is we still have no Tor browser for iOS because there is no Firefox for iOS. And every time I say that, there's somebody who holds up their phone and is like, I have Firefox on my iPhone. What are you talking about? You have a program called WebKit that Apple made, and it's got the word Firefox scribbled on top in crayon. It is not Firefox. It's WebKit with the word Firefox over it. There is no actual Firefox on iOS, and that means there can't be a Tor browser yet. We've been thinking about trying to get the WebKit folks, the Apple folks, to try to add all the privacy features that Tor browser does, but that involves the world's largest monopoly caring about its users. Separate discussion. Okay, so another topic is the performance side. Here's a graph of the capacity and load on the Tor network over the past 8 or 9 years. So the green line is how much capacity the network can handle, and the purple line is how much load there is. The first interesting answer is we're up at the 150 gigabits per second on average of traffic carried. So we're Wikipedia-sized, give or take. It's a large network all around the world. The other interesting thing about this graph, back here when the two lines were pretty close to each other, Tor was no fun to use. It meant that you were waiting for somebody else's Facebook page to load before you could get your Facebook page. Now that the two lines are farther apart, it's much more common that you're not queued up behind a bunch of other people's requests, and Tor is a lot faster and lower latency and so on. A lot of people think about Tor and they say, man, I bet Tor is slow, and I bet it's slow because you're like bouncing around the world, right? There's network latency. It takes 200 milliseconds to get from this continent to that continent. Most of the reason why Tor was slow in the past is because of queuing inside the relays. We have something like 7,000 relays and something like 8 million daily users, and that means that we have far more users than we have relays. It would be great if each of you would think about running a relay. Okay, so how do you actually think about the safety side of these things? Here are two ways to think about measuring Tor's safety. The first one I was talking about before, the diversity of where the relays are. So we've got 7,000 relays all around the world, and the more different places they are, the harder it is for an attacker to be able to watch the traffic going through each of them. So that's the first notion. The second notion is much more confusing to the computer science folks, and that has to do with the diversity of who's using it and why. So let's take Iran as a good example here. Let's imagine you're the dictator in Iran, and you want to stop people from using Tor. If you weren't very good at political science, you would say, look, what I'm going to do is I'm going to find a Tor user, I'm going to publicly kill them, and I'm going to repeat until there are no more Tor users. And the reason why that doesn't work is that the average Tor user in Iran is the average Facebook user. They block Twitter, they block Facebook. Everybody who's between the age of 20 and 50 goes out to get something like Tor in order to get around the censorship. And that diversity, that ordinariness of users is why it's safe to use Tor in a place like Syria and Iran and so on, because the average person using it is not a political dissident. They're not saying, fuck my government, I'm going to change things. They're saying, my government blocked my pictures of kittens. I need to see my pictures of kittens, so I'm going to install this thing in order to be able to use the web like I could last year. And that ordinariness is key for having it be safe to use the tool. So far, so good? Okay, and as an interesting example of that, I was recently learning that apparently the CIA had like 40 people in Iran a few years ago, and they all got identified and killed. And they also had like 40 people in China who all got identified and killed. And the simple version, as I understand it, is that the CIA rolled out their own privacy system for themselves. And then Iran noticed somebody using it, and then noticed all the other people using it, and then killed them all. And so this is an example of how not to build a privacy tool, because you need that variety of users in order for the network to be safe to use. Another interesting side from the Tor perspective, transparency. So it's free software, it's open source, we give you the design documents and so on. I guess there are three key pieces to the transparency in the open source side. So we give you the source code so you can actually look at it and see what it does. We also give you the specifications that say, this is what we tried to build. So that means you can compare the source code to the specs and say, that thing you built isn't what you said that you tried to build, so I found a bug. And then we give you the design documents that say, this is what we're trying to do. This is what we're hoping to accomplish. And that way, if you're a researcher, you can look at the design documents and the specs and say, you said you want this, but the way you're doing it doesn't achieve that. And that way, no matter what you're good at looking at and analyzing, there's a way for you to jump in and help try to assess whether we're doing it right. So another key piece of transparency is us showing up and saying, hi, I'm Roger, I'm a Tor person, happy to answer your questions until you don't have any questions anymore. There are other tools out there like I2P where they don't really identify themselves. And building that trust as human beings by going around the world and meeting people is key to having a community that's based on trust. So transparency is not just about, here's the open source software. It's about, we are actually human beings, and we're happy to talk to you and explain how things work and answer questions. And I get a lot of, every time I say this, there's somebody who's like, oh, haha, the Tor people, the privacy people are talking about transparency, oh, haha. It's not a contradiction. Privacy is about choice. We choose to be transparent in order for you to be able to build that trust in what we're doing and how the system works. Do you buy it? And then yes, what about bad people? There's always somebody who's like, well, you know, but bad people are using the internet, and how are you stopping them? So there are a bunch of different answers to that. One of them is there are millions of people using Tor every day, and a few people on the internet are bad, but one of the challenges we see is if you're like law enforcement, you find a bad person using Tor, you assume that privacy is stupid, so there are probably only like 6 users, right? And I found 2 and they're bad, so most of Tor is bad. If Tor is working for those millions of people, nobody sees them, nobody notices it. So it's really easy to have the wrong instincts about how much the Tor network is used, because it's not visible. There's no, you don't get to meet all the 8 million people, so it's hard to have an instinct about how to compare that. So that's the first answer. Remember, there are a whole lot of people using it for ordinary things. Another answer is maybe it's a two-edged sword. You know, you got to accept the good users with the bad users. And I think that's true, but it's really an unbalanced situation right now. The bad guys on the internet are doing great. If I want to have privacy, I build a botnet. If I don't care about laws, there are a lot of different ways of illegally getting privacy on the internet. Let me try to expand on that one a little bit more. So imagine 2 scenarios. Scenario 1, I want to build a tool that works for millions of people, and it works for the next 10 years, and I can tell you all about it. That's the Tor problem. Scenario 2, I want to build a tool that works for 20 people for the next 2 weeks, and I'm not going to tell you about it. That's the terrorist problem. That's the bad guy problem. So it doesn't have to scale, doesn't have to handle like public scrutiny, and nobody has to know about it. It's short-term, transient. There are so many more ways of solving scenario 2. Get in a flame war on Wikipedia, hide your message in like an image on eBay or something. There's so many things that don't work long-term, but they're fine as long as they don't have to scale. So the bad guys are doing great. They have so many more options than Tor has in terms of how to achieve safety on the internet. So yeah, good people need Tor. Good people benefit from Tor a lot more than bad people do. Another way of framing that is, imagine if we took Tor away from the world, would the bad guys suddenly disappear from the internet? Whereas the millions of people who are using it to stay safe would have far fewer options, and there wouldn't be a system that scales and has this cover traffic of millions of other people around. So far, so good? And there's always somebody who's like, no, 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 I fight bad people, I want to argue with you about this. So that's, we'll get back to that one. So Steph added a couple of interesting user stories to the slides, so we'll see a couple of them as we go through. I'm a political activist, part of a semi-criminalized minority. I want to actually publicly debate things, and I end up getting harassed by my government. Tor allows me freedom to publish my message to the world without being personally persecuted for it. So this is an example where we said, hey, Twitter, tell us what you use Tor for, and a bunch of interesting people showed up with their real-life stories of why they care about Tor and why Tor is important for them. I remember long ago talking to the brother of a mayor in a little town in Maine, and the mayor had to be, a real politician, and the brother wanted to do a blog on being gay in a little town in Maine. And that mayor was never going to get reelected if the brother actually identified himself while he was doing that blog. So he was able to host a pseudonymous blog and do what he wanted to do on the internet without ruining the political career for his brother. Another, I'm a doctor in a very political town. I have patients who work on legislation. When I have to do research on diseases and treatment, I'm well aware that the search histories might be correlated to patient visits. I use Tor to do much of my research when I think there is a risk of correlating it to patient visits. Another very reasonable reason why you might want to not have your internet traffic smeared all around the world. I was talking to a fellow from Finland a while ago who was researching some disease at work, and he got fired because his work was like, oh, I wonder if he has the disease. I don't want to pay for an employee who's going to get sick. I'm just going to get rid of him now. That's like super illegal in Europe, but it still happens. And it's not even super illegal in America. It happens all the time. So do you want to be revealing to whoever's watching and buying your data sets what you do on the internet, what you're interested in? And I mean, you might be researching a disease because your mom has it. Not because you have it, but how is somebody surveilling you going to know the difference? Maybe they'll jump to conclusions. Another fun part of the Tor world is the Library Freedom Project. They've got a cooler logo than this. This is the old logo that somebody made. How many people here have heard of the Library Freedom Project? I see one hand in the back. Okay, so there's this great woman named Allison. She's a library science person, and she goes from library to library teaching them how to do trainings of the people who go to their library on how to be safer on the internet. It turns out in the US there are censorship requirements on libraries, and librarians are not really big on censorship, so they're a great audience for how to do trainings around the world and get more people helping out and knowing how safety works. Okay, so talk number 2. This is the Tor front page from a lot of countries around the world. So here we are, surf safely, this website is not accessible in the UAE. Or I guess this one, yeah, here. The website has been blocked for violating something in laws of the Kingdom of Bahrain. And here we are in the Sultanate. This site has been blocked due to content contrary to the laws of the Sultanate. If you believe that we shouldn't be blocking this, please fill out your name and your address and all of your details and send it to us, and then we'll contact you if we think we need to. So there are some other interesting examples of, let's see, the next one, we've got one in, trying to figure out which countries these are at this point. So access to the site is currently blocked, the prohibited content categories of UAE's internet. And then down here we've got something from Qatar, the web page you were trying to access has been blocked, and they're trying to make it fun. They've got like the cartoon characters that are like, this is great, it's all fun. You went to a website that's kind of weird, but oops, it didn't work. And there's a whole industry for marketing this to people in a way that makes the fascists not look like fascists. So they try to make it, oops, we're fascist, this is fun. So this is the way that a lot of people around the world see the Tor website. So this is the censorship piece of things. The very first graph that the Tor Metrics project made was the set of people using Tor from Egypt back when Egypt did its Tahrir Square thing. And you can see very clearly on the graph where Egypt blocked Facebook, because a whole lot of people started using Tor in order to get around the censorship. And then you can also see very clearly on the graph where Egypt unplugged its internet, because there we are flatlined there. And my favorite part of this graph is afterwards, there are a lot more people using it than before, because there are a lot of people who are saying the military is still watching everything, the surveillance is still in place. You're darn right I'm going to keep on using this privacy tool because, yeah, the West says that we just had a revolution, but this is not over. So that was long ago. This is a much more recent graph of Tor use in Russia a few years ago. And it starts with 200,000 people or something, and then we have a few 100,000 added, and then they disappear, and then they come back, and so on. I was actually talking to the chief security officer of Facebook, who says they have the exact inverse of this graph in their secret internal data set. So Russia blocks Facebook, hundreds of thousands of people switch over to using Tor, the blocking goes away, and they all stop, and the blocking comes back, and they resume. So it's interesting that our public data sets are sort of the mirror of the secret corporate data sets that people have around the world. There's a more interesting, more recent version of this graph from the Ukraine, where over the course of a week, we added like 700,000 people from the Ukraine using Tor. And we didn't know what was going on. We were looking at it thinking, man, that's 700,000 people in a week. That's either a huge social media campaign, and probably not because we can't find it, or is it a botnet? Did some jerk in the Ukraine just sign up 700,000 compromised machines? It turns out there's a website called vk.com, which is like the Russian Facebook equivalent, and Russia convinced Ukraine to censor VK. And it turns out that VK has a whole lot of users, and they own a bunch of other little companies, including a web browser. So they integrated Tor into their web browser, not for every destination, but just a whitelist. If you're going to these 12 domains that don't work from the Ukraine, route that traffic over Tor. So 700,000 people upgraded their browser, 700,000 new Tor users in the Ukraine. They didn't even know what Tor was. They didn't know they were using Tor. Websites magically started working at that point. Okay, so I talked at the very beginning about what happens when countries start to block connections into the Tor network. Even if Tor is really good at the whole privacy, anonymity, security thing, if you grab a list of the Tor relays and block them, then you can prevent people from reaching the Tor network. So what's the first step around that? And that's what we call bridge relays. The idea is, rather than having 7,000 public IP addresses, which are public so the bad guys can block them. Instead, let's let other people sign up what we call bridge relays. And the goal of that is you have tens of thousands of transient bridge addresses, and you give them out one at a time to the people who need them so that it's hard for China to learn all of them. We'll get back to the bridge notion in a bit. So that's the first way of blocking, which is you block by IP address, and the way around that is what we call bridges. The second way of blocking is what we call deep packet inspection, or DPI. And there are a bunch of for-profit companies out there that sell DPI tools to, they sell them to Boeing and Raytheon, but they also sell them to Syria and Dubai and so on. So the very first censorship of Tor based on deep packet inspection happened in early 2011 in Iran, where they DPI'd for the SSL handshake, and then they looked for a particular parameter inside our crypto handshake, the Diffie-Hellman prime, for those of you who enjoy cryptography. And we used a different prime than Apache uses, and that means that they could distinguish the Tor handshake from a normal web browser connecting to a normal HTTPS website. Because originally we said, let's look like HTTPS, because who would block that? And it turns out they found a little distinguisher, and we've managed to learn what it was and fix it, and then we had our users back in Iran at that point. Later on, they realized that the expiration date for our SSL certificate was always really close to expiring because we only made it for a day or something. You're supposed to rotate your keys often, and actual SSL certificates for real websites last for a year at a time. So that was another distinguisher. And we've gone back and forth trying to look like normal web browsing. But the real answer there is what we call pluggable transports. The real answer is not, let's try to make Tor look like web browsing. It's, let's separate this modularly. So Tor takes care of the privacy, anonymity, security side, and the pluggable transport transforms the traffic in some way so that the sensor is going to be willing to let it through. So here's our cute transformed onion. You'll never guess that it's actually the Tor logo underneath. And OBS proxy is one of the more successful pluggable transports we have right now, which basically adds another layer of encryption on top of the Tor flow, so there are no headers anymore. So that means if you try to do DPI, your classifier says, oh, I don't know what it is. And then the sensor is forced to choose, do I block all the I don't know what it is? Because that's a lot of false positives you're going to block. Or do I allow all of that through? And there are a bunch of interesting research designs out there on coming up with other different pluggable transports ideas. I'll mention a few more towards the end of the talk. And Steph popped in another interesting use case. I live in Iran, and I've been using Tor for censorship circumvention. Tor changed my personal life in many ways. So we've heard from a lot of people around the world who are using Tor on the censorship side of things. The other fun thing about the modularity of the pluggable transports is that other companies and nonprofits and tools have picked up our transports, like OBS proxy and other ones, and they use them inside their tools. So there are VPN providers who use the OBS proxy module to transform their VPN traffic so it looks like obfuscated Tor traffic, and then rather than China blocking VPNs by DPI, instead they blend in with all the Tor traffic and they can use that. So part of the goal of that modularity on our side is not to have some monolithic thing called Tor, it's to have a bunch of different puzzle pieces, and whichever ones you find useful, you can put into your system and get that censorship resistance piece. How many people here know the Bluecoat story? Okay, nobody, yeah, there's always one person with one hand. Okay, so there's this company in Sunnyvale, California, and they build and sell, they're basically a small arms dealer. They think of themselves as a censorship box, or maybe they sell to corporations to keep their employees safer on the internet. The basic idea is they're going to go to Boeing or something and say, hey, install this thing and your employees will be safer on the internet. You'll get to watch what they're doing. But they also end up selling to Dubai, and it also turns out that they have been running the censorship and surveillance infrastructure for Syria for quite a while now. And the sad story about Bluecoat is years ago, the folks from Anonymous, you know, the ones with the cool masks, they found a misconfigured FTP server in Syria, which had like 5 gigabyte files just publicly available. So they pulled down the files, of course, and they were line after line of this IP address tried to go to this website, and I blocked it, or I allowed it. Timestamp, IP address, destination, yes, no. Gigabytes and gigabytes of logs of everything everybody in Syria tried to do. And at the top it said Bluecoat version 4 point something. So Anonymous was like, hey Bluecoat, what you doing running the surveillance censorship infrastructure for Syria? Because you know that's against export regulations. Here you are, looks like you're a criminal. And Bluecoat was like, nah, we're not doing that. And they're like, well, it says Bluecoat version 4 point, what do you mean? And then Bluecoat's like, oh man, you're right, we sold those to Dubai, but oh, how were we supposed to know that they ended up in Syria? Gosh. And so then Bluecoat said, but we disabled all the automatic updates, so it's all like, you know, we're done with them, they don't work anymore. So Anonymous got the serial number and like logged into the update server and gave them the serial number, and the updates were offered. So basically Bluecoat lied every step of the way. And the end of the sad story is, and then the US State Department awarded Bluecoat like a human rights award for their cooperation in the research. So I don't want to pick on Bluecoat in particular. I hear they got bought by Intel or whoever it was, so now they're... Symantec, great. So I mean, all of these little arms dealers end up in bigger arms dealers who don't even know that that's what they bought. The bigger problem is this whole cycle of people building tools like this, and then I was actually in Tunisia at one of the software fairs for this, and they had people there with brochures saying how many bloggers you can find and execute per hour. Like, they are shameless in their brochures about this. Which leads to, I was in a meeting a few years ago in the German Foreign Ministry where they were trying to figure out, what should Europe do? Should we regulate the Italian companies and the German companies that are operating the surveillance infrastructure in these countries? Should we make it against the law? And it was a weird meeting because I was basically the only technical person there, so periodically the diplomats would lean over and say, hey Roger, what does the technical community think about this? And there I was trying to represent the whole internet to the German diplomats, which was a weird position to be in. And in general, every time government people try to draw a line, my stuff's on the wrong side of the line. So I don't want them to just declare good software, bad software. One of the interesting recommendations from a guy from Privacy International was, don't look at the software, look at the advertising brochures, look at the marketing, look at how they're framing their thing. And if they're framing their thing as allowing you to maintain your dictatorship, then maybe that's not something Germany should be comfortable with. The other interesting lesson from that one, there was a telco guy from UAE. How many people here know the phrase lawful intercept? One hand. Okay, so whenever routers are built and sold in America and Europe, they have a built-in backdoor mandated by US law. And that backdoor is designed for lawful intercept. In theory, the feds go to a judge, and the judge decides whether spying on that person's traffic is okay, and then they give you a warrant, and then the feds use the warrant to go to Comcast and spy on the person. Imagine when you take that same router with that same lawful intercept port, and you plug it into the Dubai ISP, and the Saudi prince or whatever, whoever's there is like, what's that for? And that's the lawful intercept port. Oh, I am the law, plug it in. So the expectations about the judicial oversight that may or may not be working out in practice in the US and Europe are definitely not working out there. So this telco engineer from UAE was like, look, you guys made us put the back door in, and now you're angry that we're using it. You're mandating that all of your internet infrastructure has the back door, and now you're angry when we use the back door that you made in the internet. So there are a bunch of different layers of this argument. We should talk more about that one afterwards. And it's worse than that. Australia censors the internet. England censors the internet. Denmark censors the internet. Sweden censors the internet. So that means that when Western governments go to China and say, you're being a bad country, you're censoring the internet, China quite reasonably says, look, I'm keeping my citizens safe just like everybody else. Why are you picking on me? Of course I'm protecting my citizens on the internet. So I guess the flip side of that is, if we can't solve the fact that Australia is excited about censoring the internet, how are we going to solve the fact that China and Vietnam and Bahrain and so on are interested in censorship? And so here are the actual, honest-to-God, official cyber police of China. They are the logos, they're cute, it's fun, I'm just watching you, don't worry. As long as you do the right thing on the internet, it's fine. How many people here, I'm trying to figure out what topics I should cover in the last little bit. I could talk more about how China censors things and how China tries to censor Tor, or I could move on to other stuff. What do you want to hear most about? Onion services, the dark web, that sort of thing. Okay, so I'll cover this very briefly for those who are interested in asking afterwards. So I talked earlier about pluggable transports that transform Tor traffic into other stuff. One of the things that China did as the next step, if they classify and they can't figure out what it is, they spin up a new, what we call active probing. They make a connection to the server side, and they talk obfs proxy and Tor. And if the server side talks the right protocol back, then they know that they found a thing they want to block, and they block it. So there is a nationwide active probing infrastructure inside China that can react within milliseconds to things that look like they might be VPNs, or look like they might be Tor, or look like they might be obfs proxy, and then do an active connection and talk the protocol that they think it might be in order to reduce the false positives. And there are mechanisms, there are ways of building your pluggable transports so that you are active probing resistant. The basic idea is the user, the client side, needs to have a password or a passphrase or a secret or something, and then they connect to your obfs proxy server and they prove knowledge of the secret. And if the person connecting to you doesn't know the secret, your job is to act natural, whatever that means. Your job is to be like, no, I'm going to pause for a little while and then hang up. Because if you provide any headers in response, that's a fingerprint, that's a signature that they can use to say, that's obfs proxy trying to pretend not to be obfs proxy. So there's a whole arms race in how to look like everything or look like nothing on the internet. So if you're interested in that, talk to me more afterwards. I'm going to skip over some more of these things. So here's the actual front page of one of the documents that Ed brought out. Turns out that when Ed was collecting all the documents he could, he found everything he could find about Tor and made sure to bring it and give it to us so that we would know as much as possible about what NSA and GCHQ were doing with respect to attacking Tor. So this is in June of 2012. They had a 1 week at NSA and 1 week at GCHQ. It was a workshop called Remation 2. Makes you wonder if maybe they had a Remation 1 earlier. I think they probably did. I think it was in June of 2007. So basically, this slide deck was somebody talking through all the ways they tried to attack Tor and failed. Tor stinks, we don't know how to break it. So that's good news. It's much better than having, actual smoking guns or whatever the metaphor is. But this is also 2012, and that's kind of a while ago, and maybe the NSA, they don't really talk to each other very well, so maybe there was a group in the NSA who was doing better than this group, and Ed didn't get their slides because they were better at. So there's a lot of uncertainty there in terms of what we can actually conclude from this, but cautiously, it's it's good news that everything that we learned about the NSA when Ed published everything was that they had failed to figure out how to break Tor. The other fun part of this is one of the pictures that everybody saw, and there he is with the Tor sticker on his laptop. That caused a lot of CNN-style journalists to be like, so what is this Tor project that Ed started? And we were like, oh, well, hold on a minute, let me teach you. Because they knew about EFF, but they sure didn't know about Tor. And there's also a fun endorsement phrase from, I don't know if it's NSA or GCHQ. If you happen to know which group said this, it's in one of their slides. They described Tor as still the king of high secure, low latency, internet anonymity. There are no contenders for the throne. We've been trying to figure out, for April Fool's Day, should we rearrange our Tor website so that it's entirely endorsements by intelligence agencies? There are some fun ways of handling that one. Okay, so I'm going to skip over some more of the censorship stuff, but I'll mention briefly this thing called Snowflake so that you can talk to me afterwards if you want to. So I talked earlier about pluggable transports that transform Tor traffic. We're working on another one where the transform turns the traffic into WebRTC, which you might not know what that is, but you do know what Google Hangouts is. WebRTC is the video chat protocol behind all those websites that you use that do video chat. So the idea is a volunteer in a web browser runs some JavaScript that turns their browser into a bridge. So rather than saying, hey, can you apt-get install Tor and edit this text file and run this thing on a command line, you say, load this URL, and then you have hundreds of thousands of people who are bridges in their browser for that transient session, and they're Google Hangoutsing with the censored user, and then connecting that traffic into the Tor network. So now there are hundreds of thousands or millions of transient addresses, and if China wants to enumerate all the people running web browsers and block all of them, that seems like a harder task for them to do. So happy to talk more about that one afterwards. One of the lessons there, the censorship arms race sucks, because I used to think it was me against like the Iranian government or something. Maybe I can handle that. It's not. It's me against 1,000 PhDs at Cisco who think it's fun to build new ways to censor the internet, and then Cisco goes and sells their product to China and all the other places. So the censorship arms race sucks because of how unbalanced it is, but at least you know whether you're moving forward. Like you try to make a connection, it doesn't work, you change what you do, now it works. There's a feedback loop. You know whether you got unblocked. The surveillance arms race is even worse because I wonder if they're watching me. I'll change something. I don't know if they're still watching me. There's no feedback loop. So maybe we need to have a new ed come out every week with a new set of documents about what they're seeing. I don't know how to make that feedback loop quicker. And it's worse than that because the internet is a lot more centralized than you think. There's like 6 cables that go across the Pacific Ocean, and basically every intelligence agency wants to go watch those 6 cables. So you might think of the internet as this huge dispersed thing, but there are choke points, bottlenecks that make it more easy to look at than you might imagine. Okay, so talk number 3 or 4 or whatever it is. Tor onion services. How many people here have heard the phrase onion services? A lot more. Awesome. Okay. So all the stuff I talked about before was I want to connect to a thing on the internet where I'm getting safety while connecting to the thing. Now let's turn that around. I want to run a service on the internet where people can reach my service, but they don't have to know where I am in order to be able to talk to me. They just talk to me through the Tor network. And the basic idea is both users build circuits into the Tor network and they rendezvous together in the middle so that Alice doesn't have to know where Bob is, Bob doesn't have to know where Alice is, and the rendezvous point in the middle just knows that it's gluing together 2 Tor users of some sort. So the way this works in practice, the user experience is you've got this blah blah blah.onion address up here, and you type it in just like another normal address, and the Tor client says, oh, that's an onion address, that's special. I'm going to do the rendezvous dance in order to be able to connect to the destination that corresponds to this onion address. Now, the address you see up there, the blah, 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 is the hash of the public key of the onion service, and that gives us a bunch of cool properties. The main one is if you have the right address, your Tor client can guarantee that you're talking to the place on the other side that has the private key whose public key hashes to the address you're going to. So it's self-authenticating or self-verifying. That people here know the phrase certificate authority, CA, the whole mafia where like Turkish Telecom can pretend to be any website on the internet and China Telecom can pretend to be, and there are 250 other companies that are all trusted to pretend to be anything on the internet. We totally bypass that. There is no need for a centralized for-profit certificate authority. The names themselves prove that you're talking to the person that you meant to be talking to, assuming you got the address right. So that's the self-authenticated part. End-to-end encryption comes for free because you're talking within the Tor network. So of course, as part of the rendezvous process, you establish a session key so that you know that nobody else can be listening. And it comes with some other cool features. You can run your onion service from behind your firewall, and you don't have to let any other traffic come through. So there are a bunch of sysadmins who run their like SSH server for controlling their computer only as an onion service, and then they firewall everything. So now the only way that they can reach their computer is through that onion address, which they know they're reaching it the right way. They know nobody else will be able to reach it that way. They don't have to worry about random jerks on the internet finding their computer on the internet and trying to break in. So those are some of the cool features. A while ago, there was some Fed who busted some jerk on the internet who was like selling drugs or something. And they ended up coming up with some sort of like press release about how we shut down like Silk Road or whatever it was, and half of the Tor network disappeared. And I was like, well, shit, that would be a huge amount of traffic because we're pushing 150 gigabits per second of traffic. So, man, I don't think that's true, but I wonder if it's true. And it turns out if you don't have data and the other person lies and pretends to have data, then they win because they're the ones pretending to have data. So then we were thinking, let's actually start instrumenting the Tor network, and let's figure out, how much of Tor traffic in general has to do with onion services. Because onion services are a toy that I wrote back in 2004, and we've never really figured out how to make them scale and how to make them usable enough that ordinary people find them useful. So there probably isn't that much use. But how much use is there? So here's a graph of the total amount of traffic on the Tor network that has to do with onion services at all. It's about 1.5 gigabits or something. So something like 1% of the traffic on the Tor network has to do with onion services. And there's some complicated math because it's how much at the relay side or how much at the client side. But the very short version is about 3% of the traffic going into the Tor network is onion service traffic. So about 97% of the traffic going into the Tor network is going to Facebook or Twitter or Google or whatever people do on the internet. They're watching their kittens and doing the ordinary internet things. So approximately 97% of Tor has nothing to do with onion services. So when this Europol guy or whatever he was says half of the Tor network traffic was this guy selling drugs, it's very clear that even if all of onion service traffic was this guy selling drugs, it was at most 3% of the Tor traffic. So it's a tiny little piece of what Tor is. So next time you see a picture of the iceberg and a phrase, the dark web, and they're trying to explain that there are 99 other internets out there and you don't know about them and you can only get to them through the Tor browser, it's all bullshit. To a first approximation, there is no dark web. There are something like 7,000 websites out there running as onion services, and in a few more slides, I'll tell you a few examples that explain like a tenth of the onion services that are out there. So part of the problem is long ago, there was an article from Time magazine that had a picture of a spider web, and they tried to explain that there are 99 other internets and you don't know about them, and they're only available from the Tor browser. It's nonsense. That there is no factual stuff behind that. I don't want to say there are no jerks on the internet. I don't want to say there are no jerks using Tor, but the volume that people talk about, and you end up with like Hollywood television shows with a dude on a hoodie and like a green screen and so on, it's all bullshit. Speaking of which, what would you think is the largest website on the dark web? I moved to the slide so you've got a good guess. It's not some jerk selling drugs. Facebook set up an onion service because somebody inside Facebook a few years ago started looking at their internal data set and said, wow, during April of like 2016, 1 million people logged into their Facebook accounts over Tor. So that's like 0.1%, 1 in 1,000 of the Facebook user population was using Tor during that month. So they used that internally to convince Facebook, look, these users are wanting security. We've got users in Turkey who are getting man in the middle getting to Facebook because that's what Turkey does. So let's give these users, the ones who want more safety, the ability to get some safety. They want safety, we can do it, let's do it. So Facebook set up an onion service, New York Times set up an onion service, there are a bunch of high-profile places that set up an onion service. Apparently the CIA set up an onion service last week. So a lot of people look at this and they're like, but Facebook is spying on you, I don't understand. So why would you connect to Facebook over Tor? I don't get it. Even if you're connecting to Facebook over Tor, even if you're logging in, why should they know that I'm in New York today? Why should they know anything more than what I choose to tell them? Tor is not about making everybody anonymous by default. Tor is about giving you the choice, giving you control over what you're going to tell to people. So maybe you make a fake Facebook account because you're a Syrian blogger and you want to use a different name, and they don't have to know who you are. Or maybe you log into your Facebook account, but until you tell them what you had for lunch that day, they don't have to know where you had lunch that day. They don't have to know that you're in this building right now. So it's about controlling who you show your metadata to. Another challenge we have on the Facebook side, I was talking to some like threat intelligence company. I have to wave my hands every time I say dark web or threat intelligence. I was talking to some threat intelligence company who said, I found a copy of Facebook on the dark web. And I was trying to figure out, how do I explain to this person, there's a web server somewhere out in the world, Facebook runs it, it's called Facebook, And you can get to it over HTTP, you can get to it over HTTPS, you can get to it over .onion. It's the same web server, it's the same website. There's no cloud, there's no cyber, there's no dark. It's the internet, and this is a different way of getting transport security when you go to the same website you'd be going to any other way. And then it's about choice. It's about the users get to choose. Do I want this sort of security? Do I want this sort of security? What kind of security do I want? Another way of thinking about that, imagine two scenarios again. So the first scenario is you're trying to go to a website, but you're not sure which website you're actually going to go, and you're not sure who's going to be able to look at your traffic while you're doing it. Scenario two, you know exactly who you're talking to, and you know that nobody else is able to watch you go there. Which of those would you call dark? I might go for that first one, the one where I'm not sure who I'm talking to, and I'm not sure who's surveilling me. Don't you want a system where you actually know that your metadata, your transport metadata, is secure? Another way of looking at this, so if you watch the television shows with the cool people with hoodies, you think that like dark web, onion services, online bad guys, stuff inside IBM's corporate firewall, they're all sort of mushed together, right? I don't understand, but it's all like the dark web. So the first thought is, what do they mean by dark web? Are they talking about onion services? Because if you call people running websites as Tor onion services like Facebook, if you call them the dark web, are you leaving out the criminals? Are you leaving out the like stuff Google can't reach? That's kind of weird. Or do you call the bad guys the dark web? Which that seems like a legitimate answer. The more threat intelligence companies I talk to, the more I realize that they don't even mean Tor anymore. They have to say dark web because their sales team says dark web, but more and more they find like some random Russian website, and that's where their entire credit card dump comes from. It's got nothing to do with Tor at all, but they have to say dark web because everybody else says dark web. So more and more, I think that's the answer. That's what the dark web is. It's the criminals somewhere on the internet. Or maybe they're talking about IBM's corporate database. Is that the dark web because Google can't find it? I don't know what people mean. And let's keep scale in mind here. Are they talking about that tiny little yellow thing? Is that the dark web? Because there are a lot of bad people on the internet, and if they're not the dark web, what's going on here? So what are some interesting examples of onion services that are deployed right now that gives you some taste of what people can use onion services for? So Secure Drop is a fun example. This is a way for you to reach journalists, and there are something like 30 different groups like the New York Times and a bunch of other really high-profile places are running Secure Drop servers. And the idea is you can talk to a journalist there and give them documents and have a back-and-forth conversation where you're in control of how much they learn about you. It's not, I want to go to CIA.gov and click on, I want to submit an anonymous tip, which is a fucking terrible design if you want your users to be safe. It's the whistleblower, get to choose how much safety, how much identification, how much you need to convince the journalist. Because journalists want to know that it's a trustworthy source and, where do you get that? How much do you know? Let's talk this through. But that doesn't mean you have to tell them where you are or who you are any more than you want to. So there are a bunch of different secure drops out there. Another interesting example of onion services, it's not a I want to run a website that somebody wants to shut down example. How many people here use XMPP or Google Chat or Signal or iMessage or all these messengers? I bet everybody uses a messenger. Most people are just not raising their hand. So the problem with pretty much all of these architectures is they're centralized. Like even systems like Signal, they have a list of all your friends. They know when you're online. They know when your friends are online. They know when you talk to your friends. So there's a juicy middle that they promise not to lose. They promise nobody will ever break in, nobody will ever buy it, nobody will ever accidentally leave it in a taxi. That's not a very good architecture. So the ricochet design is every user is their own onion address. So I have a list of my friends based on their onion address, and we rendezvous to each other over the Tor network, and there's no middle. There's no place that the government can go to send a subpoena or that the mafia can send a guy to pick up the database. There's no juicy middle to attack. It's just a bunch of people talking to each other over the Tor network where everybody is in control of their own privacy. You don't have to delegate that to some Apple chat service. Another fun example is Onion Share. So let's imagine you're a journalist at The Intercept, and Ed Snowden just gave you a bunch of cool documents straight from the NSA, and you're sitting physically next to another journalist, and you want to give them all the documents. How do you do it? You send them to the other person over Gmail, but Google's watching everything. That's probably not so good. You upload them to Dropbox, and then they fetch them, but Dropbox actually probably sells all of its stuff as well. They're certainly watching it all. You set up an FTP server and then teach the other person what FTP is, and then they fetch it. That probably doesn't work because nobody uses FTP anymore. You stick it on a USB key and you hand it to them, but everybody knows that USB keys are dangerous, so nobody uses them anymore. The answer that The Intercept came up with, and they actually use it between journalists, is a tool called Onion Share, where you have a file you want to share. You drop it onto Onion Share, which spins up a web server on your computer in Python, a single-use web server, and it gives you this URL, and then you send that URL to somebody over Signal or Ricochet or SMS or whatever, and then they paste that URL into their Tor browser, they download the file, and your Onion Share goes away. So it's a transient website, transient web server, for just sharing that one file that one time, and then everything's gone afterwards. So I try to explain this to law enforcement, and it just blows their mind, because they're used to the world where there's a web server, and you go there 3 months later, and it's still there, and you ask them for logs, and that's not how the future is. This is a way of sharing a file safely through the Tor network as an Onion service in a way where nothing is there once you're done. Okay, so what are some interesting conclusions or thoughts to think about here? I've listed 4 ways that you can screw up using Tor, and I tried to order them by frequency of how people screw up. The first one is operational security mistakes. You try to use Tor, but you accidentally put your name on the blog post, or you try to use Tor, but you accidentally use Chrome instead of Tor Browser, oops. And every time, so one of my side hobbies is doing talks for law enforcement to try to explain that, yeah, their job sucks, but it's not my fault that their job sucks. And every time I do a talk, there's somebody who comes up to me afterwards from like the FBI or something and says, I was trying to bust this bad guy and I couldn't because they were using Tor and it was really frustrating, but I kept watching and eventually he logged in from an open wireless network, so I went and arrested him. Every time I do a talk for the FBI, there's somebody there with that story. So using tools like Tor or any sort of privacy security tool, using it correctly is key. And it's hard to do because everybody wants to get sloppy and nobody wants to think through every time they're about to do something, am I doing it right? So that's the number one hardest thing about staying safe on the internet. Number 2 is the browser metadata. Tor Browser tries to patch a bunch of Firefox problems, but now that Firefox and Chrome are both running towards having as invasive a browser as they can, Chrome is trying to make everything surveil as best it can, and Firefox is trying to be competitive in the browser market, which means if Chrome builds a battery reading JavaScript API, then Firefox has to think about building a battery reading JavaScript API. And last I checked, Chrome had a new API where the website you go to can ask you to enumerate the UUIDs of all attached USB devices on your computer. Like the website you go to can ask what's attached to your computer. And that's because Chrome is like it's like a Nintendo console or something. So if you have like a joystick attached to your computer, Chrome should let you do that automatically. It should just be seamless. And so more and more browser invasive things are happening. And how do we catch all of them before they get out into the hands of users is a hard one. The third one that's much more rare, but also something to think about. Browsers are these huge, complicated pieces of code. They have bugs. There's a whole ecosystem of people paying hundreds of thousands of dollars for Chrome exploits, Firefox exploits, Brave exploits, and so on. And law enforcement groups buy these things and use them when they want to. So the Firefox people are working hard on sandboxing Tor better, but that's a crappy arms race because of how much money is in that space. And then the fourth category, which we haven't really seen to be a problem in practice, but it's one that we want to think about from the research side, is the traffic analysis side. Imagine you're NSA or Five Eyes or something, and you've invested a lot on surveilling a lot of the internet. Tor is on the internet, so can you see enough in order to be able to do the traffic analysis side of things? In practice, they don't have to do number 4 because people screw up on number 1, or they buy a browser exploit and so on, so they don't get there. Okay, so what are the ways that you can help? I'm going to pause while the siren or whatever it is works its way past us. So one answer is please run a relay or run a bridge. This summer we're going to be ready with Snowflake that I was talking about before, so you can install like a browser extension and you'll be volunteering automatically as a bridge for people in China and other places where they need to get around censorship. Please teach your friends what Tor is. When your friend starts talking excitedly about the dark web, this is your chance to be like, no, dude, I met the Tor guy, and let me tell you what's actually going on. The dark web is not what Hollywood is trying to convince you of. And I mean, we're not going to be able to re-educate people about the dark web. I can't compete with Hollywood's press people, but increasingly it's clear that the dark web has less and less to do with Tor. I was talking to one of these threat intelligence people who said, we have an account on Pastebin. We have like a professional login to Pastebin, and Pastebin sends us everything that jerks try to dox each other about. They put it up on Pastebin, so we get a copy. All the stuff that these companies get that they find interesting comes from Pastebin. It doesn't even have anything to do with Tor Onion services at this point. So part of what we need to explain is, yeah, there are bad people on the internet, and they're being bad to each other, but what does that have to do with Tor? We've got millions of ordinary people who are doing ordinary things on the internet, and they're trying to be safer while they're doing it. And if you want to help find and fix bugs, or if you want to work on research, there's a conference called PETS, Privacy Enhancing Technology Symposium, that's happening in July in Stockholm. And another thing that you folks in particular would be great for, we're a nonprofit. We rely on donations, and some of our funding comes from US government grants. Some of it comes from groups like Mozilla that try to match the individual donations. We're trying to build up the foundation side of things with MacArthur and Knight Foundation and so on, but that's a tough road to go. So the more of you that can help us be able to continue building Tor, the better it will all go. And I'm going to delegate a little bit to Steph to say a little bit about this part, if you want.
Yeah, we just added this to our site, and it was a pretty big deal for a nonprofit figuring out the best way to do this, because we have to switch over the funds immediately. So this actually took a lot of work, and we're really excited to have so many options, and hope that you can help us out so that we can keep doing this work that is unmatched by anyone else.
Yeah, it started off as a bit of a challenge because, so if you get a certain amount of US government funding, you have to audit yourself every year to prove that you're handling all of your money correctly. Imagine going to a bunch of old auditors and being like, look, we're doing best practices for handling our Monero. The auditors are like, I don't even know what that means. So part of the way we've set this up is we instantly convert it back into US dollars or something. So this is, we are accepting a growing variety of cryptocurrency. Once you're taking Dogecoin, you're basically taking everything. So please help in whatever way you can. And if you want to help spread the news to your communities about how useful it would be for us to still be around, that'd be great.
For the relays, is there any hardware that you'd suggest? Like, is a Raspberry Pi helpful?
Yeah, so the question is for the relays, what do you need? Early Raspberry Pis are too weak, but Raspberry Pi 3s are doing fine. The real question for the relay, there are two questions. One of them is, how much bandwidth do you have? It's not about CPU, it's about the network connection that you've got. And most Raspberry Pi 3s can handle most network connections. The other answer is, every relay has an exit policy that lets you specify what destinations you're willing to let people reach. You can say, I want to let people browse the web, but no IRC, for example. And about 2/3 of the relays say, I want to be a non-exit relay. I just want to let people, I want to be the first hop or the second hop, but not the third hop. And that way, I'm never the IP address that people get confused about when some jerk does something bad on the internet. So if you run an ISP, if you have an ISP that's friendly, running an exit relay makes a lot of sense. We need those even more. But if you aren't in that situation, running a non-exit relay is safe and helpful.
Thank you. So I'm curious about what your thoughts are of the Tor integration of Brave, how they made it so fast, and also your thoughts on VPNs and their roles, for instance, what Google is doing with Outline. Yeah, just your perspective on that.
Yeah, so the Brave thing is a bit tricky. So in my world, there are two pieces to what Tor is. There's the network level privacy, and there's the browser level privacy. And Brave at present is doing the network level privacy and has plans to do the browser level privacy. And that means it's not ready yet to be what I would call Tor, because they have a bunch of open tickets on how to prevent the website you're going to from de-anonymizing you by sending you certain traffic that makes you go around the proxy, or that makes you give them fingerprints and cookies and so on. So I think Brave has more work to be done in terms of doing both halves of what Tor is. But I like the idea of more and more browsers providing application level privacy. Firefox is also thinking about, so part of the challenge is private browsing mode is a lie. And so Google looked at, they call it incognito mode or whatever it is. They looked at that and they're like, no, it's cool, we'll just let our users be confused, it's fine. And Firefox looked at that and they're like, okay, so we're going to put a bunch of fine print explaining that you don't get what you think you get. And that way, we at least did our job. And then DuckDuckGo did a survey asking people, what do you think private browsing mode does? And they all said, I think it keeps me safe from my ISP. I think it keeps me safe from the website I go to. I think it keeps me safe from advertising companies. So wouldn't it be cool if rather than trying to put a bunch of fine print explaining that you're wrong, you just make that true? You just ship a Tor client in the browser, and that's what private browsing mode is. Mozilla wants to do that. So we need to figure out a way to scale to the point that, that we can handle that much traffic. Maybe we start with a button called actually private browsing mode, and then some people find that button and choose it. So given that we have 8 million daily users, I think we could handle a lot of people doing that. So, and then your question about VPNs. I don't know about Outline in particular, but in general, VPNs suffer from the centralization problem that I was talking about before. And I want an architecture where you have privacy by design rather than privacy by promise.
So I'm from South Africa, and one of the biggest problems that we have is availability of bandwidth. So we have completely shit internet and
Yep. We used to have some relays at major universities in South Africa, but they never last for some reason.
That's why.
Yeah.
So now, you know, in a country where we're hitting a lot of political strife right now, one of the big things that people are starting to realize is, you know, anonymity and things like that matter to them.
Yep.
And how do I now try and convince them to vote on, or how do we get buy-in to something like Tor without, or like with the very poor bandwidth that we have in mind? Like, you know, that's a big impact. I mean, people, they still want to go on Facebook, they still want to do their stupid stuff.
Yep. So using Tor from South Africa actually works pretty well.
Okay.
I did it when I was there. It's okay. Running relays, having more relays all around the world would be helpful for the diversity side of things,
Yeah.
but it's actually more complicated than that, because if we put a bunch of relays on Mars, then the traffic latency as you're going through the Tor network would sometimes be really bad because you go to Mars and you come back.
Yeah.
So there's a trade-off between the security you get from having relays in a diverse location and the performance you get from having relays all in Germany. And we, the Tor network, need to have some balance somewhere in between there. So I think if you found a good, cheap, fast internet connection in South Africa, running a relay there would make sense. If there are 0 of them, maybe get a VPS somewhere in, maybe not Germany because that's where everybody else is, not the Netherlands because that's where everybody else is, but Croatia or something where they've got a pretty good internet and there aren't that many relays right now. Another way of answering that, I talk to a lot of people who are like, I've got my startup plan and I want to send a bunch of traffic over Tor, but it'll be like 10 gigabytes a day. Is that okay? And one answer is, The Tor network is a commons, so if you're loading it down, you're ruining it for somebody else. I think the better answer is, think of it like carbon offsets. If you're going to add 10 gigabytes onto the Tor network, make sure that you run relays that offer 60 gigabytes back, and then you're part of the community, and you're making sure that everything grows.
Yeah, you talked about how centralization has a lot of negative things with security and privacy, but it also seems like these centralizations around design help with metadata resistance with Tor, like making sure that the browser size is the same and that all the traffic looks really similar. So as Tor's...
I would call that uniformity rather than centralization. But yeah.
But for other people who are trying to implement the Tor browser, like sort of centralize these, I guess, design aspects or uniformity aspects, while also still encouraging sort of decentralization.
Yeah, I think having large communities on Tor who each look like each other is pretty good. It doesn't have to be that all the Brave users have to look like all the Tor browser users, as long as there are enough Brave users. So part of the risk there is that you set up your own foocoin thing that has 8 excited users, and you hope that's a large enough anonymity system. So a large enough anonymity set. So you either need to look like a fingerprint that has a lot of other users looking like it. You either need to be one of those, or you need to choose one of those and look like it. And that's an area where there's a lot of open research on how best to do that. There are periodically browser research people who say, don't make it uniform, randomize it. Randomize this, randomize that, randomize that, randomize that, and then it's all confusing. And there are a few problems with that. One of them is you end up with contradictory things, like you say, I'm using JavaScript version 0.1, which nobody does anymore, and I'm Internet Explorer, and I only speak Japanese, and suddenly you have things that will never happen on the real world, and it messes up your browsing experience more than it needs to. So we currently think that making it all uniform is the best answer, but there's always a trade-off there. Like right now, we enable JavaScript by default, because most of the internet will break if we turn it off. But JavaScript is a source of some, not all, of the browser vulnerabilities. So if we really wanted to keep people extra safe, we would reduce the surface area in the browser by disabling things that everybody expects. And that works for the first 50,000 Tor users, and the next 8 million Tor users are deeply confused that your browser is broken. So as you scale to handling the average internet user, you have to do what the average internet user expects.
So you talk a little bit about Snowflake. You see that as a replacement for a domain fronting style system? And the second question is, where do you think Tor is going in terms of bandwidth? Like, are you always going to do that? You're always going to weight the bandwidth towards the higher performing ones, using those more in yours?
Yeah, so how many people here know the phrase domain fronting? I see a couple of hands going on. Okay, so there's this cool trick that you used to be able to do, and it kind of sort of still works. And it's a way of getting around censorship. The idea is that you do an SSL handshake with www.google.com. So from the censor's perspective, they think you're doing a Google search. Once you've done the SSL handshake, inside the encryption layer, you send the HTTP host header saying, I want to go to AppSpot. So from the observer's perspective, you look like you're doing a Google search, but Google allows you to reach any of their services from any of their services. So they let you SSL to search, and then you head off to Google Cloud, which runs a bridge into the Tor network. So you look like you're doing Google search, but you're actually talking to the Tor network through Google, and that forces the attacker to either block Google or not block Google. And the censored person in China needs to be able to say, hello, I want a snowflake. I want to connect back. I'm over here. Can somebody please send me a bridge or something? So you can do that with domain fronting. You can connect to Azure and through that to the Snowflake broker. But it doesn't have to be like, I'm not actually sending the whole Tor traffic back and forth. So it could be some little trick. And it turns out there are a lot of little tricks that don't scale, but you can send a thing and get a response. Amazon has one called SQS, Simple Queuing System. Google has this thing called AMP, something mobile pages, where you can send a little thing and it works its way to the website, which answers and works its way back. And as long as Google AMP isn't blocked or Cloudflare AMP isn't blocked, then you can do the initial rendezvous.
I guess the issue is like it seems like China and Russia are willing to block these massive services. So like, do you see any solution to that, or?
Well, yeah. So another version of that is, in order for Snowflake to work with the NAT piercing, you need a stun server in order to do the actual handshake, the video chat handshake. And there are plenty of stun servers in the world, but Google runs the big one, so that's what everybody uses. And if China blocks that, is Google gonna, what did Google do last time China blocked something in their system? They did a big press release about how angry they were, and then they kept on doing it. So I don't know how that arms race will go. But we need to explore, rather than the collateral freedom idea of that service is too big to fail, they'll never block it. We need to do the let a thousand flowers bloom. There's a little service over here, they've never heard of it, we'll use that for a while. There's a service over here, we'll use that for a while. And maybe that will move forward. You also, go ahead.
Is there another?
Yeah, the second question was just about bandwidth waiting routing, and do you think you're going to keep doing that? Because it makes the top routers are in more fast than the...
Yeah, so we used to wait uniformly, meaning no matter how fast your relay is, it gets the same amount of traffic. And that produced huge hotspots on the not very fast relays, where if you happen to pick them, you'll be very sad using Tor. And right now we don't, so there's an ongoing research project on how best to measure how fast a relay is, because right now the tools that we use aren't very good, so we're mismeasuring them, which means we're giving relays more attention than they should have or less than they should have, and Tor is not as fast as it could be. So we're hopefully soon, we'll finish on that better measurement infrastructure, and we'll be able to put the right amount of traffic on each relay. But you're totally right that it's a balance between security versus performance. And we just need a lot more relays and for them all to be fast, and then we don't have to worry about the problem as much.
I think we can take maybe one more question.
We're going to be kicked out in 30 minutes, I'm told. So
have you looked at all into protocolizing the incentives around running a relay? Because right now it just seems like altruism. And so if it would scale, especially in that example with the startup, you ask them to do the give and take of running more relays, but is there plans to make that
yeah, so there are a bunch of interesting research papers on how do we come up with tokens, or how do you incentivize these things? And we haven't figured out the right answer for it right now. Let me give you a couple of different answers. One of them is in the psychology literature for volunteers. There are some surprising results that make me nervous about going down this path. For example, there are a bunch of psychology people a while ago who studied people who volunteer at a soup kitchen. And at the end of the day where they're helping out, serving food to people, you say, thank you very much, here's a t-shirt. And they say, wow, this is great, I've got a t-shirt, I helped somebody, this is awesome. Or they say, thank you very much, here's $4. And when you say, thank you very much, here's $4, they start valuing their contribution at $4, and they're like, fuck this. Why am I wasting my time doing a thing that's only worth $4 to the world? So one of the risks is if you bring money into the situation, then the people who are doing it because they want to make the world better leave, because they're like, fuck this, I'm not in it for the money. And then you have this weird system that's only designed for money, and if you get that wrong, then people start misvaluing their contribution, and then they leave, and then you've destroyed the Tor network forever. So there are some downsides. A different way of answering that, imagine you're running a relay and your goal is to make money off of it. So your goal is to minimize cost and maximize revenue. So I'm going to put my relay in that same building in Germany that everybody uses because that's the cheapest hosting. So now we're centralizing the Tor network again. And maybe you could design some sort of smart contract thing that like pays more if you're in Poland than it does if you're in Germany, and maybe people wouldn't cheat by lying about where their relay is, or maybe you could solve that one. But even then, if your goal is to maximize your income, imagine the feds come to you and they're like, can you tell me who that user was? What are they doing? You're like, oh, I can make even more money if you pay me to do that too. So part of what we need from relay operators is for them to be part of a community where it's a group of people who all know that they're in it to make people safer rather than in it to make money. And if we could come up with some way of doing both of them without losing the in it to keep people safer, that'd be really interesting. But all the ways that I've seen so far turn it into a libertarian money-grubbing free-for-all, which would change the social structure of the system.
All right, well, thank you everyone for coming. Let's give Roger a round. Before we go, I want to give a huge thanks to DystopiaLabs and Global Coin Research for making this happen. So thank you. And we will be here for a few more minutes if you want to ask any more questions or pick up a t-shirt or make a donation. So thanks again for everyone for coming.